Hello, welcome back to a new video in the Java for Beginners series. In this video, we're going to cover a bunch of operators and operations in Java. So we're going to discuss arithmetic, relational, logical, assignment, increment and decrement, operators and operations. So let's get started.
The arithmetic operators, the relational operators, so these do math, these do comparisons, greater than, less than, equals and not equals. The logical operators, anding and oring, and the not operation. If you're not familiar with those, it's okay, we'll explain them further when we get to them. And the assignment operations we've seen those before, at least this one, but we'll see those additional two later on. And the increment and decrement operators. So we've not spoken about those, but we'll talk about them briefly after. Let's begin with the arithmetic operators. So we've got addition, subtraction, multiplication, division, and the modulus or the remainder. Pretty straightforward. I guess these also are examples, and the signs are pretty familiar, I guess, to everybody. Maybe except for this one, though. This is the sign for the remainder operation. Let's go have a look at some examples. So I've got an example here, and remember that these variable names are not really great variable names, but just for an example, it's fine. So I'm gonna hit run and see what's gonna happen. I got the answers for these operations: addition, subtraction, multiplication, division, and modulus. Now keep in mind that these are called expressions, like a plus b, a minus b, a multiplied by b, etc. These are arithmetic expressions. So an expression is basically a construct that is made up of like variables. You could have like literals in here, so I can have 1 and hit run, so that'll be 11, the first line, and other things that we're going to see later down the line, and other kinds of operators. So I want to also bring your attention to this over here that I have in my comment. Now notice that a divided by b, which is 10 divided by 3, it produced 3. So that is the same answer as if I've divided, 9 by 3? Why is that the case? Well, it turns out that this operation is very special because it is presuming that we're doing integer division. And so the answer is always going to be an integer. How do you override that? All right, let me take a second to explain this, because whenever you're doing any operation that involves two different types, there might be a type promotion depending on what kind of types you're working with. So remember we said we have byte, short, int, long, float, double. And this category is the category of numbers, right? So if you do a table where you say byte mixed with byte, byte mixed with short, trying all the possibilities, then you come to the realization that there must be a decision to be made. For instance, if you're doing a division for like float over integer or integer over float, like if you're dividing 13.2 by 2, well then where do you store the result? Like what kind of variable or memory location does the result occupy? Does it occupy an integer? But then it loses data because integer cannot describe a floating point. Or do you use float? If you're doing short and byte, which data type do you use? Well, it turns out there's a very simple rule that you can follow to figure out what is going to be the resulting data type. All right, to explain the type promotion, I've got this diagram here. So if your operands are a mixture of short byte, then the resulting type is going to be integer, okay? So you never end up with a short or byte as a result of mixing those two. Now, if you have an integer within the mix, but none of these types, then you also end up with an integer. If you have a long in the mix and none of these types, then the result will be a long. If you have a float, but not a double in the mix, then you end up with a float. And if you have a double anywhere, then you end up with a double. Well, I could add float to one or the two arguments, and that will be enough to change it to a non-integer division, a floating point division. What if I add double? Can I do that? Which basically what we're doing is we're casting the integer value into a collective double value, like that whole thing that is highlighted turns into a double value. And notice with double, we've increased the precision, like the number got bigger. And we're dividing a double over an integer, and then the outcome is going to be double because double takes precedence in division. Now, the second type that we're going to look at is the relational operators, the comparison operators. So as you see here, they typically produce either true or false. So they produce a Boolean type. Remember Boolean? So if you want to compare if two, say, numbers are equal to each other, you use the double equal. If you want to compare if they're not equal, you use the not equal. If you want to compare if one is bigger than the other, you say 10 greater than 5. Well, it's going to be true. If you said 5 greater than 10, that'll be false. And then you have the less than 5 less than 10. That is true. Greater or equal. So when you know how like you say 5 is greater or equal to 5, and that'll be true. So the way you say it is the same way you write it. So you start with the greater than, and then you put the equals. Same for like less than or equal. You get the point. Let's look at some examples. All right, let's look at this example here and notice that I did something slightly different this time. So instead of just putting in the answer in a print statement, I did something where I have, do you remember how we had hello world? Yeah, and it was in a thing that we call in Java a string that we're gonna visit later on. But no, it's just a bunch of text and characters, right? And if you want to print something next to a string, you can use string concatenation. So that's a string, and I can concatenate to it another string, hello world 1, 2, 3, or I could concatenate to it an expression. All right. So this being an expression, x double equal y. Is x equal to y? Well, x is 5, y is 10, so that's going to produce false. You get the point. Let me try and run the application to see what's going to happen. So our first line, we got the two strings concatenated. Our subsequent lines, we've got the operation that we're performing in textual format and the answer for that operation or the result of executing it. Notice how I added extra parentheses around the expression. You must add them. If you don't add them, you're going to run into an issue that we're going to discuss why the issue is happening down the line. For now, you may want to just add those parentheses and they'll just isolate the expression. So as in like this now is an expression that will be evaluated to either true or false. And then here will be something like false or true, which like it's okay to have true or false concatenated with a string, but it's kind of not okay to have an expression concatenated. And we're going to talk about why later down the line. Don't worry about the why, just follow blindly for now and add the parentheses around your expression. And just to show you the result of executing this, I'm going to comment out the rest and I'm going to hit run. And I got that true right there. And I can even concatenate a number. So that's not a string, as in there's no double quotations around it. So it works with some things and it doesn't work with some other things. So just leave it the way it is for now again. Follow blindly. Next, we're going to talk about assignment operators. But before we do that, let me show you something in the IDE. Let's say that I have a variable called x, and the value is 1. And I want my program to figure out what the value of x is and increment it by 5. So what do? Maybe what I do is I say int y equals x, and then I say x equals y plus 5. And if I s out x, what do I get? Should get 6 printed. I get 6 printed. Now it turns out I don't need this variable over there. I just don't need it. It's redundant. I can just replace the y with x. And then I'll run it again and see what's going to happen. I get 6 printed. So how did that happen? All right, so here the value of x is 1, right? So I come to this line here, and the first thing that gets evaluated is what's over here on the right side of the assignment operator. So as of right now, the value of x is 1. Add 5 to it, the value becomes 6 here. And then what do you do with this? You store it in x. So x's value becomes 6. And then I print that over here. So I can do that with, so the value over here will be 6. So I can say x equals x multiplied by 2. And I should expect 12 to be printed. And if I hit run, I see 12 being printed. And I could say x equals x divided by 3. And I should expect 4 to be printed. You get the point. All right, so let's talk about the assignment operators, right? So we spoke briefly about, and we've seen examples about the just vanilla operator, assignment operator. And it basically evaluates whatever on your right hand of that operator and stores it in the whatever in the left hand. So here we have 5. It could have been 5 plus 2. It could have been x multiplied by 5, whatever it is. Right, so the other assignment types are basically shortcuts for doing what we just did. So if you want to do x equals x plus 5, you could just do x plus equals 5. And that will translate into that. Same for minus equals, x equals x minus 5. Multiplied equals, divide by equals, and modulus equals. It should be pretty straightforward. All right, so I've prepared some examples here that we can look at. So I've got an integer x equals 10, and then we can print the initial value. Then we can print all the modifications starting with a plus equal, minus equal, multiply by equal, divide by equal, and then modulus equal. So I'm just gonna hit run, and I'll see all the values being printed. And if we actually add a new line here, final value of x should be 3. Perfect. Let's talk about increment and decrement operators. So turns out for a very special case of adding 1 or subtracting 1, as in like x equals x plus 1, x equals x minus 1, the things that we've seen before. So for adding or subtracting 1 from the same variable, we have special syntax for that. So you could say plus plus x, and it would add 1 to x before it uses x. If you say x plus plus, then it would use x in the context that x is in, like let's say printing x, then it would add 1 to x. And the same goes for minus minus. It would subtract 1, then use x, or it would use x, then subtract 1. Let's go ahead and see some examples. All right, consider the example here. I have an integer that is called value, and I've assigned 5 to it. And I'm printing out the value, which should be 5. Then what I'm doing is I'm doing a post increment. So use the value, then update the value, add 1 to it. So what we're expecting to be printed is 5. Then we add 1 to it and it becomes 6. So moving on to the next line, the value of value is 6. So 6 will be printed here. Let's have a look. All right, as we've expected, we have 5 being printed, then 6 being printed. All right, so I've added more operations to our code. Okay, now I'm going to show you a concept in programming called debugging. What is debugging? Debugging is the ability to step through the code line by line. And you know, it's called debugging because a bug is a misbehavior in your code, and debugging is trying to find the bug. But sometimes you don't have a bug, like in our situation here, and we just are interested in stepping through the code. So instead of hitting the run button, I'm going to hit the debug button, and I'm going to come here in this area and I'm going to click, and that will create a breakpoint. So our application will start and run, and then it will stop here and wait for us to continue its execution, as in like step through to the next line and the next line. So give it a second, it will start. And I'm just gonna make this a little bigger. Now this part here, don't worry about that. I want you to look at the console here, what is being printed. So anything that is being printed by system.out.println will appear here. And these are the variables that we have currently in our scope. Don't pay attention to args for now. Args is this one. We'll talk about it later. All you want to pay attention to is the value variable that we have. Make sense? Okay, so I'm going to bring the mouse and hover over this area of the code. And then you see run to cursor. You see that? So I'm going to click that. And then clicking that, I've executed this line. And I'm stopped at this line now before executing line 9. So I'm after executing line 7, but I'm still before executing line 9, right? And having executed line 7, I got initial value plus value printed, which is 5. Now, if you execute this line now, line 9, you get postfix increment, and the value is 5. But if you look here, so the value that was printed is 5, but if you look here, the value is already updated to 6. So the next time we print, we're gonna get 6 printed. Now, of course, you may see things that are being printed that are not related to our code, like profiling started. Just ignore that. It's okay. It's a whole different topic that we're not gonna get into. Just focus on the stuff that we have in our code that we are printing. So I'm going to continue and print this line, which is the the prefix increment. So I'm expecting an increment before I use the value, before I print. So the current value is 6. So if we do a prefix increment, then it's going to become 7, then it's going to be printed. So I'll execute that, and I see the value is 7, and 7 is printed. Cool. And then when I move on to the next one, the value is 7, and I got 7 printed. And then I'm going to move on to the next one, where this is a postfix decrement. So the value will still be 7 when I print, but then it will be decreased, and the value here is expected to be 6. So I'm going to move on, and I see that 7 was printed, and 6 is the current value. And then I'm going to move on to the next line. This is just going to print 6, the value as it is. And then I'm going to do a prefix decrement. So this is going to decrease the value before I use it, i.e. is going to decrease the value before I print it, which is going to produce 5. Then I'm going to print 5. So let's do that. I got 5 printed, and the value is 5. And then if I print just merely the value, I'm going to get 5 as well. So I may as well just use this button to resume the program. So this will basically continue running the program as usual, without really stepping through any lines, unless it hits any more like breakpoints in the code. But there is no breakpoints up until the end of the scope, if that makes sense. Like if I had a more lines under and a breakpoint at some point, I'll show you in a second. So I'm just gonna hit this now, and then the program finishes execution, and value after prefix decrement is 5. So if I hit the debug again, and I'll add a couple breakpoints just to illustrate what I was talking about. So I can hit this button, and it will release the breakpoint and release the debugger until it hits another breakpoint. So I'm right here, right now. I can hit this button, and then I'll jump to the next breakpoint. And if there is no breakpoints, like if I remove this breakpoint, then the program is going to continue executing until it terminates. Feel free to experiment with debugging. It's really helpful to inspect the state of the memory at any given point in your application, and it just helps you understand how Java works. And now we're going to talk about logical operators. Now, logical operators, if you're not familiar, are and, or, and not. There's a lot more, but we're just going to focus on those 3. So let's start with and. Now, when you're dealing with logical operators, you're combining 2 logical values, or Boolean values, true, false. So with and, it works like multiplication. If you replace true with 1 and false with 0, then it really works like multiplying 1 by 0. So you could say true multiplied by true is true, as in 1 multiplied by 1 is 1. True multiplied by false, or 1 multiplied by 0, is false, or 0. False by true is false. 0 by 1 is 0. And false by false is false. So you only have true if both are true. And any other case, the result will be false. Now moving on to OR. OR works like addition. So replace each true with 1 and each false with 0. So true and true is true, as in, is the value of the addition not 0? Kinda, yes. 1 plus 1 is 2, so it's not 0. True plus false. Is the value of adding 1 and 0 is not 0? Then yes. Is the value of adding 0 and 1 is not 0? Yes. Is the value of adding 0 and 0 is not 0? No. So it's quite the opposite to AND, in the sense that if you have true anywhere and it just takes one true, the whole thing will be true. And if you don't have any trues, then the thing will be false. Now, the last operator we're going to talk about is the NOT operator, which will switch a true to false and a false to true. Pretty simple. All right, let's look at some examples here. So I got condition A and condition B. And notice that I'm using the Boolean type because it's either true or false, right? So condition A is 5 less than 10. Is that true? Yes, it is true. Condition B is 2 is not equal to 2. Is that true? Oh, oops. That should have been false. My bad. So the second condition, is 2 not equal to 2? That's false. So we're going to combine condition A and condition B. Remember how AND worked. If not both of them are true, then the answer will be false. So the answer of combining the two will be false. However, if you say condition A or condition B, then the answer will be true since at least one of them is true. And if you invert or not a condition, as in if you take the value of condition A, which is true, and you invert it, then that's going to be transformed to the opposite, false. Let's run the code and see what's going to happen. So I get condition A and condition B is false, as we expect, because one is true, one is false. But the ORing of them is true, because at least one of them is true. And the inversion of a true value will be false. I hope this makes sense.
Thank you for watching the video. I hope it was helpful for you to understand operations in Java. And if you liked it, you know what to do. And subscribe if you haven't. And I will see you in the next one. Take care.